Okay, let's go through test 3. All right. So I'm going to write these down on some paper as we go. F of x is x squared minus 2x plus 7. And g of x is x minus 3. And we want to know f composed with g. Okay, so this is the same as f evaluated at g of x, which is going to be the same as f evaluated at x minus 3. That's the equation for g. Now, what was the equation for f? I'm going to rewrite that with blank parentheses wherever there's an x. And I'm going to put in the blank parentheses x minus 3. But of course, we cannot leave it like this. It has to be simplified. X minus 3 all squared is that. Then minus 2x, distribute the 2, plus 6 and plus 7. Here I'll have x squared minus 3x and plus 9. 6 and 7 is 13. And so I have minus 6x minus 2x, which is minus 8x. And 13 and 9 is 22. So that should be my answer. And it said enter it as you would on WebWorks. Don't use extra spaces. So I want x squared minus 8x plus 22. Okay. All right, now I have this, and you want to find f composed with g of negative 2. If you've got a number in there, your answer is going to be a number. And quite a few of you wrote some equation that involved x as your answer, which is not correct at all, and which shows, alarm bells with a misunderstanding of what is asked for. So let me copy this down. And we're supposed to have f composed with g at negative 2. Okay. So this is going to be f evaluated at g evaluated at negative 2. What is g evaluated at negative 2? Well, everywhere there's an x, I replace it with negative 2. And so g evaluated at negative 2 is negative 4. And so what is f evaluated at 4? Well, everywhere there's an x, I replace it with negative 4 in parentheses. And that will give me positive 16 plus 8 plus 7. So that's 24 plus 7, and that should give me 31. So you get a number if what's inside there is a number. So 31 should be my answer if I didn't make a mistake there. All right. Now, f of x is the common logarithm of x minus 5, and g of x is x plus 12, and we're asked for the domain of f composed with g of x. Okay. So the domain of that is going to be any restrictions on the formula. And then also any restrictions in the formula that comes second. Now with g of x, there's no restriction whatsoever. X can be anything and it won't make that blow up. So there's no restriction on x for g of x. So we don't have to worry about that. We just have to get the formula and look at any possible restrictions. So f evaluated at g of x is f evaluated at x plus 12. And then everywhere you see an x in the formula, You're going to replace it with x plus 12 in parentheses. And 12 minus 5 is 7. Okay, now, if you have a logarithm of something, then what is ever inside has to be strictly greater than 0, has to be positive. You're not allowed to take the logarithm of something negative. You're not allowed to take the logarithm of 0. So it's different from square root. Square root of 0 is fine, but with logarithms, you cannot have logarithm of 0 or logarithm of something negative. So whatever's inside here has to be strictly greater than 0. So what's inside has to be strictly greater than 0. So what is the restriction on x? How do you get x by itself? Subtract 7 from both sides. X is strictly greater than -7 in interval form. If it's strictly greater than -7, then we do not include -7 and everything to the right. And in interval form, I start at, but I do not include -7, and I keep going forever. So that's what I'm going to look for. This one here. Okay, use the table to find G composed with F of 3. Okay, I might try and do this on the screen. Okay, let me move this over here. Let's get the blue one out. Okay, so G composed with F evaluated at 3 is the same thing as G evaluated at F of 3. Now, what is F evaluated at 3? Well, the number inside the parentheses is my x value. So when x is 3, F evaluated at 3 is -1. So F evaluated at 3 is -1 from the table. So I'm going to replace F of 3 with -1. Now I have to find G evaluated at -1. So if x is -1, what is G of -1? So if x is -1, where does that intersect with G of x? And G of -1 is equal to 0. And that is my answer. And so I put 0 in here. Okay, so now let me get an eraser and look at this one. What is F composed with G evaluated at 1? Well, it's the first one evaluated at the second one evaluated at 1. So I need to find G evaluated at 1 first. G is the red graph. So I look for the point whose x coordinate is 1 on the red graph. There it is. So that's the point 1, 7. And what does G do? It maps 1 into 7. So I come back here, and G evaluated at 1 is equal to 7. So that's the same as F evaluated at 7. Now I look at the blue graph, and I find the point whose x coordinate is 7. There it is. And that's 7, 1. And F maps 7 into 1. So F evaluated at 7 is equal to 1. And so that's my answer. Okay. All right, now for this one, okay, this is our function f. Now the question is not what is f of 13. If the question were what is f of 13, then you look for the x coordinate that's 13, and f maps 13 into -7. That is not what you've been asked for. You have been asked for f inverse of 13. So for f inverse, you look for the point whose y coordinate on f, whose y coordinate is 13. F inverse maps y into x. And so f inverse of 13. So this set are all points on f. So the answer there is 11. So my answer for this is 11. All right, use the graph of the given one-to-one function to sketch the graph of the inverse function. Okay. All right. So let's look at this. Now, this is f. How do I find f inverse? I swap the coordinates. So 1, 4 is on f, so 4, 1 will be on f inverse. So 0, 2 is on f, so 2, 0 will be on f inverse. -2, 1 is on f, so 1, -2 will be on f inverse. And -4, -2 is on f, so -2, -4 will be on f inverse. So what I've drawn there in red is what f inverse is, and I have the points labeled. And so I need that to be start with 4, 1. Now to scroll down, I'm going to have to get rid of that. 4, 2, nope, that won't do it. 4, 1, yes, that's the only one that it possibly could be. And all those points check. All right, given the graph of the function f, what is f inverse of -1? So again, the question is not what is f of -1. The question is what is f inverse? And a lot of you gave the wrong answer and answered it like it was asking you for f. So what does, if I have a point on f, so suppose, oh, let me get the blue one. So suppose x, y is a point on the graph of f. Then f maps the x coordinate into the y coordinate. If f is 1 to 1, then f inverse maps the y into the x. Okay, this is the graph of f. So what is f inverse of -1? You try to find the point on f whose y coordinate is -1. And then what f inverse will do is it will map the y coordinate into the x coordinate. And so here is the point on the graph of f whose y coordinate is -1. And the coordinates of this point are 3, -1. And f inverse maps the y coordinate into the x coordinate. So f inverse of -1 is 3. The question was, what is f inverse? And a lot of you answered that question as if you were being asked, what is f of -1? So the answer here is 3. All right, the function is 1 to 1. Find its inverse. Okay, so I might do this on paper. F of x is equal to 9 over x minus 5. Okay. So the first thing you have to do is rewrite this with a y. And then you have to swap x and y. then you have to solve for y. You have to get y by itself. So I see a lot of papers back in the olden days when we had things submitted on paper, and the first thing someone would try and do is add 5 from both sides, thinking that would leave. No, you can't do that. First thing you got to do is get rid of the fraction. Y minus 5. That cancels and leaves you 9. Now you're going to have x times y minus 5, and so you're going to have to multiply it through. Now everything with y stays. Everything that doesn't have y goes. Add 5x to both sides. And now to get y by itself, divide everything by x. Now that's a correct answer. Or you could have put these into the same fraction, which would have been 9 plus 5x. So either one of these is correct. So now let's have a look at the selections. Here, okay, I wrote it as 9 plus 5x over x, but that is the same thing, so that's our inverse. Okay, determine the domain, the range, and the domain of the inverse and the range of the inverse. Well, that's using the fact that if it's 1 to 1, then the domain and the range of each other are just swapped. So f of x equals 3x plus 1. F of x equals 3x plus 1. Let's get the domain here is there's no restriction on x whatsoever. X can be anything. There's nothing. We don't have a fraction and we don't have an even root. We don't have a logarithm, so there's no restriction on x. That's my domain. Now, what about the range? Well, it also looks like it's not restricted because the range is what f of x can be. And f of x can be anything. It can be any negative number up to infinity. Okay. If you don't see that, you can find f inverse. Swap x and y. Solve for y. There is no restriction on x whatsoever. Yes, we have a fraction, but x is not in the bottom. And so this is my inverse. And the domain, there's no restriction. But the domain of f inverse is the same as the range of f. And the range of f inverse is the same as the domain of f. Okay, so my range here is also going to be y is from negative infinity to positive infinity. So this one should have domain and range of both functions, all real numbers. Okay, so it's not that. Nope. Okay, f of s, domain all real numbers, range all real numbers. And f inverse of x, yep, that's the one we want. No restrictions at all. Solve this equation. Give the correct answer as a fraction. Okay. Let's get this erased. Okay. And I'm going to put these together using rule number 2. So I'm going to have logarithm of base 2. And what goes in the top is x. And what goes in the bottom is x minus 2. And that will equal 3. Now I'm going to do the conversion. That's my a. That is going to be my x. That is my y. So a to the y equals x. And now write it in the original color. 2 cubed is equal to that. multiply both sides by x minus 2 to get rid of the fraction. So this is 8, so I'm going to have 8x minus 2 times 8. These cancel. Subtract x from both sides and add 16 to both sides, and then divide both sides by 7, and we have x equals 16/7. Now 16/7 is a number bigger than 2, so when I check back in the original, 16/7 minus 2 will be positive, so it's allowed. 16/7 is positive, so it will be allowed. It said give the exact answer as a fraction, so 16/7 is what we want for our answer. Okay. All right, now we are asked something very important here. We are not asked for the solution. We're asked for the extraneous solution. And if you do the method that we did in class, you should be able to get the extraneous solution. If you figured out how to program your calculator, you'll only get the solution. It doesn't give extraneous solutions. So this is what the department does to make sure everyone is actually working these through and not using a calculator to give the answer. I put those together using rule number 2. And I will have the natural logarithm of a quotient, and in the numerator is x plus 15, and in the denominator will be x minus 1. I have single logarithms on each side, so by the uniqueness property, the arguments are the same. So what I do now is I get rid of the fraction. I multiply both sides by x minus 1. So this will cancel, and I'll have x plus 15 equals x squared minus x. Get everything to one side. I'll have x squared, subtract x from both sides, and then subtract 15 from both sides. And that will factor as x minus 3 times x plus 2. X minus 3 times x plus 5. No, it won't. X plus 3 times x minus 5. Two numbers that multiply together give me negative 15 and add up together give me negative 2. Now, what's the solution to this? The solution to this is x is negative 3. That would make the whole thing 0, or x is 5. Now, we have to go back to the original equation and see if the answer fits in the original equation before we get the solution. Now, what happens if I plug negative 3 into the original equation? It's fine here, but it's not fine there, because negative 3 minus 1 is negative 4. You cannot take the logarithm of something negative. And so this is my extraneous solution. What about 5? Is it a proper solution or an extraneous solution? If I plug 5 into there, I have natural logarithm of 20, which is positive. If I plug 5 into there, I have natural logarithm of 4, which is positive and positive. This is the proper solution. You were asked for the extraneous solution. And so for this question, we have to put in the extraneous solution. Which one does not work? Which one is the extraneous solution is what was asked for, and it's negative 3. Okay, again, we are asked for the extraneous solution. So again, if I can get rid of this, it takes so long to erase. Okay. So what we're going to do here is I'm going to put those together using rule 1. And so I'm going to have the logarithm of x plus 2 times x minus 1 equals 1. And since it's log by itself, it's understood that the base is 10. And now I'm going to do the conversion. That's a. That is x. And that is y. So I have a to the y equals x. And now if I go back to the original color, I'll have 10 to the first power equals all of this. I'll go ahead and do the multiplication. So x squared minus x plus 2x and minus 2. If I subtract 10 from both sides, I get that minus 12. And I should be able to factor that. Two numbers that multiply together to give me negative 12, but add up together to give me positive 1. So what will make this equal to 0? Well, one answer is x is 3, and the other answer is x is negative 4. Okay, that will satisfy that equals 0. Now we must go back into the original equation and make sure it works. So if x is 3, I get positive inside the parentheses 5. If x is 3, I get a positive 2 inside the parentheses. So this is a proper solution. What if x is negative 4? Well, I put negative 4 inside here, and negative 4 plus 2 is negative 2. So the inside the parentheses is still something negative. So this does not work. This is our extraneous solution. It's not a solution, but we were asked what was the extraneous solution, not was the proper solution. So the answer here is negative 4. Okay, and one more time, we're asked for an extraneous solution. Let me get all of this out of the way. Okay. Again, I will use rule number 1 to put those together. Blue pen. So I will have log of base 3 of x times x minus 2 equals log of base 3 of x plus 10. We have single logarithms on either side. So by the uniqueness property, their arguments are the same. So what's inside here is the same as what's inside here. So I'll have x squared minus 2x equals x plus 10. And so I subtract x from both sides and subtract 10 from both sides, and that will equal 0. And now I can solve that by factoring. So two numbers that multiply together to give me negative 10, but add up together to give me negative 3. That would be negative 5 and positive 2. So what solves this equation here? If x is 5 or if x is negative 2. Now I have to go back and check these in the original equation. So if x is 5, it checks out here just fine, and 5 minus 2 is positive 3, so it's okay, and 5 plus 10 is positive 15. So this is an actual solution. But now what if x is negative 2? If I plug it in there, I get something negative. So this is not a solution. It does not work in the original equation. It is an extraneous solution, and so we were asked for the extraneous solution. And so my answer is -2. Okay. Sanjay opened his account that pays 8.2% compounded monthly. So since it's monthly, the formula we have to use is the compounded interest formula, not the continuously compounded interest formula. So what we will do is A is equal to P times 1 plus R over N to the power of N times T. That's the formula we have to use. So this tells me that R is 8.2 divided by 100. Compounded monthly tells me it's compounded 12 times a year. And this is my starting amount. And how much will we have in 10 years? So that tells me T is equal to 10. So I'm supposed to figure out what A is. So A will be P times 1 plus 0.082 all over 12 to the power of 12 times 10. And 12 times 10 is 120. And so if I get my calculator and do that, so 2500 times 1 plus 0.082 divided by 12 all to the 120th power. Okay. And it says dollars and cents. So that's telling you to round it to 2 decimal places, dollars and cents. So $5,660.44. $5,660, and it says use the dollar symbol. 5660.44. How much would you have to invest to get $6,500? So that's what you end with. Okay. That's what you want in the end. So that's your A. After 2 years, that's the time, at 5%. Compounded quarterly, so N is equal to 4. And again, this is not continuous interest. It's this formula that we have to use. So we have 6500 is equal to P times 1 plus R over N all to the power of N times T. Okay, so I need to solve this for P. How much would you have to invest? You're supposed to find P. So I just have to divide both sides by whatever P is multiplied by. And that's to the power of 8. So 6,500 divided by 1 plus 0.05 over 4 to the power of 8. And so this will cancel, and that will leave me with P. Now, do not try and round what's inside the parentheses. If you do that, your answer is wrong. You've introduced rounding error. So all I want is 6,500 divided by 1, in parentheses, 1 plus 0.05 divided by 4, all to the power of 8. Okay, so now let me do that on my calculator. So we want 6,500 divided by 1 plus 0.05 divided by 4, all to the power of 4 times 2, which is 8. Now, dollars and cents, okay, give your answers in dollars and cents and use the dollar sign. So 5885.09. If I cut it off at 2 decimal places. 5885. 5885 and then 0.09. Okay. Okay. How long to the nearest year? So if it's how long, you're going to have to find out t. How long to the nearest year? So, and also, they want it to the nearest year. So you will be required to round it at the end. So we want to find t to the nearest year. Will it take for an investment to triple? If the interest is compounded continuously at 18.31. So R is going to be 18.31 divided by 100. And if it's compounded continuously, the formula is A equals P times e to the RT. Now, your investment triples. If you start with P, what will you end with? Well, if it triples, you'll end with 3 times P. And now R is 0.1831. And then times T. Now we can cancel the P's. And I can do a conversion. That's my base. That's my Y. And the 3 is my X. So I'll do the conversion template. And now bringing it to blue, I'll have logarithm of base E of 3 is 0.1831t. So ln of 3 is equal to 0.1831 times t. And now divide both sides by 0.1831. So those will cancel and you'll be left with t. So I'm going to put that in my graphing calculator, but then it said how long to the nearest year. So I have to put ln of 3 divided by 0.1831 into my calculator. So ln of 3 divided by 0.1831. So now let me do that. ln of 3 divided by 0.1831. And what is it to the nearest year? It will take 6 years. It should be very clear. To the nearest year is 6 years. Okay. All right. Population of fruit flies has that growth rate. Again, let me all of this erased. Okay. All right. So the growth rate, K, is 0.055. The time T is measured in days. Okay, the population starts with 100, so P of naught is 100. And how many flies will be present after 6 days? So we have as our formula here, it can be refined, P of T is equal to your starting amount, which is 100, times e to the power of K, which is 0.055, times T. Now, we've been asked how many will be present after 6 days. That means you find the amount when T is equal to 6. This is a function. This is P of T. So P evaluated at 6. Well, everywhere there's a T, you replace it with 6. And so I'm going to put 100 times e to the power of 0.055 times 6. And it wants you to round your answer to the nearest number of flies. Okay, so again, let me get this out, and I'll have 100, then second ln, so 100 times e to the power of 0.055 times 6. And it said to round your answer to the nearest number of flies. So if I round that to the nearest whole number, that's a 0 there, and so this is 139 flies, not 140. Round it to the nearest number of flies. It's 139. And yes, there's a big difference, because if it's multiple choice and you have to choose between 139 and 140, you'd better know the difference. So 139 is what we should have here. Supposed amount of radioactive substance is modeled by this formula, where T is measured in days. What is the half-life? So if we're asked for the half-life, what that means is we have to find the amount of time. So find T. When the amount after time T is 1/2 what you started with. What did we start with? Well, in the formula, that number out the front is what you started with. So find T when P of T is equal to 200. Well, oh, sorry, it's A of T. They're using an A. Okay, fair enough. When the amount. Okay. So here's a formula for A of T, and here's a formula for A of T. So you set them equal to each other. Divide both sides by 400. And you've got to solve that for T. You have to solve for something in the exponent, so you're going to have to do a conversion. A to the Y is equal to X. And so if I convert it into logarithmic form, I get that. So that'll give me that. So I have, I'll do it over here, ln of 1/2 is equal to this. And I need to solve that for T. So I divide both sides by negative 0.077. And so if I do that, ln of a half, that'll give me my t. So divided by negative 0.077. All right, so if I do that, my answer is going to be ln of a half divided by negative 0.077. Oops. All right, now round your answer to the nearest day. So this is my answer for t, and so it's going to take 9.0019 so forth days. Well, if I round that to the nearest whole number, it's 9. So the half-life is going to be 9 days. The instructions say do not include any words with your answer, just the number. Okay, and the last one before, use exponential regression to predict how much debt the student will have for the 10th month after the graduation. Okay, so I have to clear out 2 lists, list 1 and list 2. And press enter. And so in my first list, I have 1, 2, 3, 4, 5, 6, 7, 8. And in my second list, I have 620, 762, 900, 1040, 1271, 1589, 1851, and 2155. And you absolutely must go back and double check. Make a mistake here and everything is ruined. And 1, 2, 3, 4, 5. Okay. Stat, go over to calc. It said use exponential regression. So that's what I'm going to do for list 1 and list 2. Okay, so this gives me, let me erase all the previous stuff. This gives me my exponential equation. Now, it says to round to the nearest dollar. You absolutely do not round until the very end. If you round any time before the end, you have introduced rounding error and your answer is wrong. So what is my exponential equation? It's y equals, it's y equals a, and I'm going to take a to 4 decimal places. 522.9767 times b, and I'm going to take b to 4 decimal places. That's a 9 to the x. Okay, now how much debt will the student have for the 10th month? And the first row are your x values, the second row are your y values. So you're supposed to use that equation when x is equal to 10. So the answer is going to be y equals this equation where you put x in for 10. So let me do it here. So 522.9767 times b, which is 1.1964 to the power of 10. X is 10. Now, at the end, round it to the nearest dollar. And because this is a 2 here, then this will not go up. So it will be 3142. It didn't tell me to use a dollar sign, so I'm just going to use that. Okay, so if I haven't made any mistakes, then that should be my result. Okay. Okay, now I did miss one, and I didn't enter my answer correctly. It said, what is f inverse of -1? And I think I said what it was, but I didn't enter it properly. No, the answer should be -3, and I left out the negative sign. So what is f inverse of -1? If it's f inverse, I look for the point on f whose whose y coordinate is -1, because f inverse will map the y into the x. And as we can see, there's the point, and the point is -3, -1. And so f inverse takes the y coordinate into the x coordinate if you have a point on f. So f inverse of -1 is -3, and I must have been talking or going too fast, and I just put in 3. The answer should have been -3. So everything else is correct. So I'm going to stop the video, and that is the solution to these problems.